Well, hello everyone. I'm Dr. Simon Berrebi, and today I'll be talking about some research that we have been conducting at Georgia Tech with our graduate research assistant Sanskriti Joshi and Dr. Carrie Watkins, who was the principal investigator on this project. So the research that I will be talking about today on ridership and frequency is about modeling the elasticity on a hyperlocal level of bus ridership to service frequency between 2012 and 2018. And not only will I present some results about the relationship between ridership and frequency, but we'll also talk about some of the recent ridership trends and the local characteristics that are associated with bus ridership decline. So Georgia Tech is part of a consortium of 10 colleges and universities called the STRIDE Center. The STRIDE Center is the 2016 US DOT Region 4 University Transportation Center, with the University of Florida as the lead institution. Our mission is to develop novel strategies to reduce congestion. And the last thing I want to tell you about STRIDE is that at the end of this presentation, I would encourage you to fill out a short survey, which you can find in the comment section of this webinar. So since we're talking about congestion and since we're talking about transportation in general, as you know, there are some major negative externalities associated with transportation. Transportation accounts for 28% of the world's energy use and 23% of emissions. It causes premature death because of the pollution and also because of traffic fatalities, in addition to the fact that traffic congestion costs time for commuters, and all of these negative externalities have a disproportionate impacts on vulnerable population. But the good news is that these negative externalities of transportation can be avoided by buses, because buses make a better use of space. And while they provide all of the benefits of mobility, which include economic development and equitable access, they at the same time minimize the societal costs. But that's only if people actually ride them. An empty bus doesn't do much to serve society. And so that's why it's so important that bus systems attain high ridership. And this is also why the recent trends in ridership should make everyone concerned. And so today in this presentation, we'll talk about some of the national trends and identify the case studies that we've developed in order to better understand where and why ridership is declining and what can be done to reverse the trend. I'll talk about some of the methodology that we've developed, the new types of data that we are using in this research, and the novel models that we have created in order to extract information from these data. And then I'll go through two sets of results. The first is on ridership and frequency, which looks at the impact of service changes on ridership. And the second is who's ditching the bus, an exploration of the local demographics associated with ridership decline. And with that, I will deliver some conclusions and we'll have time for questions at the end. So in 2019, bus ridership in the United States fell to its lowest point since 1973. That was following 7 years of consecutive decline in bus ridership, according to data from the American Public Transportation Association, which was just released on Monday. And as we saw previously, this is a problem because each trip lost to private cars adds to the congestion and the pollution and the potential traffic fatalities. And so, what is further worrisome is that some of the tools that were available in order to understand this decline in bus ridership don't really seem to apply. So when you look at the decline in bus ridership at the regional level, and you look at the amount of service miles, which historically has been the best indicator of bus ridership, while there is clearly a positive linear relationship that you can see on the left panel at one point in time in 2012, when you look at the percentage change versus the percentage change in the right panel between 2012 and 2016, you can see that it just looks like a random cloud of points. And in fact, while most of these 40 largest bus agencies increased service between 2012 and 2016, they still experienced a decline in ridership despite that. And so in order to better understand this problem, we're using some new and exciting data sources that will enable us to look at ridership trends on a hyperlocal level over time. And so for that, we're using automated passenger counters, which are essentially little laser beams installed on transit vehicle doors that count the number of legs crossing in and out. Either that or Threadle mats that based on the weight are able to estimate how many passengers are boarding and alighting. These sensors are typically connected to GPS, which allow us to know at what stop did people get on or off the bus. And so, these are truly big data. When transit agencies would dump those data, we would get anywhere between 30 million and 1 billion records. And not only that, but of course, they're notoriously messy. And that's the reason why they're seldom used for planning and why we had to develop a new method in order to analyze these data. And one way that we did that was to link the data to a standardized data source for historical transit schedules called the General Transit Feed Specification, or GTFS. And so these data are available through third parties like Data Exchange or other websites. And finally, we use the census longitudinal employer household dynamics data in order to obtain population and jobs, and also demographics available by block provided by the Census Bureau. And so we focused on 4 case studies: Portland, Atlanta, Minneapolis, and Miami. And here you can see the ridership trends for these 4 transit agencies as shown in a recent article in the New York Times. And as you can see, these 4 agencies follow the national trend of essentially declining in ridership since 2012, and especially sharp decline since 2014. Now, these transit agencies are all large to mid-size, as you can see in their number of unlinked passenger trips. They're all between 50 and 57 million trips per year. And they all have about the same amount of service in terms of vehicle revenue hours, but they are very different from each other in terms of their regional population, with TriMet in Portland that only has 2.4 million residents, whereas Miami-Dade and MARTA are in metropolitan areas that have much greater population. And also, if you look at the percentage of the population living in transit supportive density, which is defined, I believe, by the TCQSM as 3.5 housing units per gross acre. In Miami, there's almost 60% of the population that live in places where transit could potentially serve the population, whereas in the Atlanta region, only 11% of the population lives in places that could even potentially be served by public transportation. So now I'm going to talk about some of the methodology that we've developed in order to analyze automated passenger count data, or APC. So here's the framework. Essentially, we aggregated the daily ridership and frequency by stop, route, and direction within each markup. And a markup is a unit of scheduled time period. It lasts about 3 to 4 months, and that's when transit agencies will shift their schedules and make small modifications to the frequencies, to the stops, and to the routes. And so once we've aggregated daily ridership, we identified constant stop route directions. These were the locations where ridership had not changed between 2012 and 2018, although the time period slightly varies from one agency to another based on data availability. And then we compared the number of trips, of vehicle trips, so a measure of frequency with GTFS, in order to eliminate the bus stops where they're either missing trips or trips that had been counted multiple times. And from there, we created route segments, which are a collection of 7 to 14 adjacent bus stops on the same route and direction, which enable us to reduce, consolidate our sample size, and also avoid the issue of having some bus stops with almost no ridership have a disproportionate impact on the model. And finally, we combine these data with the LEHD, which are the census data providing population, jobs, and demographics. So here are some route segments. As you can see, they are pretty compact and represent a sort of unit for the neighborhood that is still connected with with the unit of service delivery, which is frequency, and service usage, which is ridership. And so surrounding these route segments, we collected population, jobs, and demographics within a quarter-mile radius around each stop. So I'm only going to show you 2 slides with equations. And I think this is important and interesting because it explains how we went about modeling, these big ridership data. And the idea was to first look at a cross-sectional model, which means looking at a model of ridership at one point in time, typically in 2012. And then later I'll show you the model for looking at the change in ridership over time. So the first thing is, we're looking at the relationship between ridership and frequency, while taking into consideration some other factors like population and jobs. And the first thing I want you to see here is that we're multiplying these variables with each other. And that's part of the Poisson model, which is specifically made for the type of count data that ridership is. And the reason why these variables are being multiplied is because when you think of the recipe for ridership, well, you need both service and trip generators, which are the population and jobs. If you think of a bus stop with very high frequency, but nobody lives there or nobody works there, it's not going to have a very high ridership. And conversely, if you think of a very lively neighborhood with very many people living and working, but no service at all or very little service, it's also not going to have a very high ridership. So this multiplicative effect takes into consideration the fact that both are needed for ridership to be high. So this population and jobs term represents the total number of attraction points of potential trip generators. And so, this is how basically we consider bus ridership with these coefficients, providing a sort of elasticity. But there's one thing that I want to point out at this point is that the relationship between ridership and frequency is endogenous. And what I mean by that is, while we're interested in the impact of frequency on ridership, and there's definitely a causal relationship there, there's also a causal relationship going in the other direction, because service planners strive to maximize ridership, and they'll provide service in places where they believe latent demand lies. And so that's something that we're going to take into consideration and address through the fixed effects model. And so the fixed effects model, considers ridership change over time, and it uses each individual location as its own control. So, it's not looking to model where ridership is happening, but rather how is ridership changing relatively, relatively in this case because it's a Poisson model, in order to look at what changes in explanatory variables can explain the change in ridership, which is our response variable here. And so here for each individual segment, which again are these 7 to 14 adjacent stops, ridership and frequency are observed at time t. And here we have this frequency term, which is interacted with its prior frequency, which, as we'll see later, enables us to look at how the elasticity of ridership to frequency is sensitive to what the ridership at that segment was in the first place. And we're also looking at the change in population and jobs to control for the potential impact that it may have on ridership. And so finally, we have individual and time-specific effects, which are essentially used to drain out of the model the individual idiosyncrasies that are associated with each specific location, only to look at the change in ridership, which is specifically what we're interested in. So now let's talk about the interesting stuff, which are the results. And I'll start by talking about the relationship between ridership and frequency. The reason for that is because it's a much stronger relationship. That's the first order effect. That's the stuff that is impacting ridership in a way that's very immediate, because transit agencies change schedules every 4 months, and when they change the frequency, that brings sudden jolts to the level of demand. So first, let's look at the cross-sectional model. What I want you to notice here is the line that's highlighted in yellow, and that is the coefficient of frequency. And what's interesting is that, as you can see, in every agency, that coefficient is greater than 1. And what that means is that the places that have the highest frequency have increasing returns in ridership. In other words, the most frequent locations have the greatest productivity, which is a measure of ridership per trip. And so this analysis is done at the route segment level. But if you look at the route level, you can clearly see this relationship as well. So here we have on the horizontal axis the daily frequency and total number of daily vehicle trips. And on the vertical axis, we have the passenger boardings per trip across stops. In other words, that's the productivity. Every time a bus pulls up at your stop, how many people on average per day are getting on? So what's interesting is that while you would expect that there would be a positive linear relationship between ridership and frequency, right? If a route that has twice more vehicle trips should perhaps have twice more ridership, we see that's actually not the case. A route that has more vehicle trips will have more passengers per trip. In other words, this relationship is exponential, and that's something that we saw in the model with the coefficient being greater than 1. And what that means is the routes that are the most frequent are essentially the most crowded. And what that means, in other words, is that the demand for buses is more concentrated than the supply. So, transit agencies could obviously maximize ridership by providing even more frequency in the places that are already the most frequent. Or another way to think about it would be that maybe it's because they're providing more frequency in these places that that generates increasingly more ridership, because people are so attracted by the reliability that frequency provides. And that's something that we can't tell based on this cross-sectional model, but that we'll be able to evaluate based on the fixed effects model, which will look at the change in ridership over time. There's just one more thing I want you to notice on this graph, and that's going to be important for providing context to some future results. And that's in the bottom left corner, Minneapolis-St. Paul has, as other agencies, a positive linear relationship between service frequency and productivity, but that relationship is not as tight as in other places. That's what I want you to remember. The reason for that probably is because the transit agency hasn't invested as much in those most frequent routes that have the greatest concentration of demand, and probably has decided to prioritize service coverage instead. And we'll soon see how that plays out in terms of elasticities. So here we have the panel results for the change in ridership over time. And what I want you to notice is that now the coefficient is less than 1 for every transit agency. And what that means is if you look at each, if you look at each individual route segment and you increase service frequency on that route segment or on that route, the ridership returns are going to be diminishing. In other words, every bus that you add on a route is going to generate less ridership than the average bus that's already running on the route. That's something you can see, although not as clearly, when you look at the same graph that I showed you before, linking first year ridership with last year ridership. And first year and last year are typically 2012 to 2017 or 2018, but it differs slightly for each agency based on the data availability. So, if one of our initial hypotheses, which is that increasing frequency generates increasing marginal returns, which could be one of the potential explanation for, why we saw that the most frequent routes are the most productive. If that was the case, then you would see routes, you would see routes declining in ridership, because this is probably, the changes in service are not the reason why ridership is declining, as I showed in the beginning, because service frequency overall in the United States have been increasing while ridership has been declining. Despite that, you would see a decline in productivity that would be essentially the same relatively for all routes, independently of the changes in frequency. But what you can see is that the routes that have increased service have typically lost productivity, and that's especially true in Portland, where most of the frequent routes increased service and saw much deeper declines in productivity than the other routes. And so that begs another question, which is the elasticity of ridership to frequency the same on all routes, or are higher or lower frequency routes more or less elastic to changes in frequency? And that's something we were able to answer by interacting the elasticity term with the prior frequency. And this is something that we can actually see here with, as shown on the horizontal axis, the weekday frequency in terms of total vehicle trips per weekday as a function of the elasticity of ridership to frequency. And what I want you to notice is that here in Portland, Miami, and Atlanta, it's a diminishing function. So the most frequent routes are the least elastic to frequency. And in Minneapolis, we're seeing the inverse effect. So in Minneapolis, the most frequent routes are the most elastic. And the reason for that is probably because Minneapolis is the city where, or Metro Transit is the transit agency where the relationship between productivity and ridership, although it's clear and it's strong, it's not as defined as in other agencies. And so it probably indicates that, you know, there is more potential growth on the most concentrated parts of the networks, which for other transit agencies have been exhausted. And so, you know, what this means is that while, you know, in all cities, the most frequent routes are the most productive, since in 3 of the 4 cities, these routes also have the lowest elasticity, you know, investing on those routes may, you know, will continue to produce, you know, high productivities, but these productivities are going to be diminishing. And then the second set of results that I want to show you are about the local characteristics associated with bus ridership decline. So first, looking at it at one point in time, you know, what we're seeing, and this is more about model calibration and verification than actually, you know, pulling some new insights, because what we're seeing here is very like obvious and was already known from the literature. Some of the demographics associated with ridership decline, you know, we're seeing the proportion of zero vehicle households is positively associated, the proportion of white residents is negatively associated. You know, 2 factors that are significant in all 4 agencies is the proportion of residents whose maximum level of education is high school is positively associated with ridership at one point in time in 2012, and the proportion of residents who are above 65 is negatively associated with bus ridership at one point in time. So this makes sense, and it's really, you know, consistent with right about everything we've seen in the literature. Now, what's interesting is to look at, we can actually look at these trends graphically. So here you have 2012 ridership per trip per capita as a function of, you know, the proportion of local residents who did not attend college. And you can see that positive relationship in all 4 agencies is clear. Unlike the previous graph that I show you, now we're looking at route segments. So there's thousands and thousands of individual data points, which, you know, explains some of the variation. But I think one thing that's interesting is that surrounding that trend line in red, there's confidence intervals for 1 standard deviation, and you can see that it's very tightly, you know, centered around the red line, which indicates that the relationship is very clear. Now, what is interesting here is that the same model enables us to look at what are the local demographics that are associated with ridership decline. And that's what we see here in this model, where, you know, the one significant variable for all 4 agencies is the proportion of white residents. In, you know, in all 4 agencies, the neighborhoods that have greater proportion of local residents who are white have declined more in ridership than other neighborhoods. Other variables tend to vary. You know, one thing that we're seeing in Miami and Atlanta is that the proportion of zero vehicle households is negatively associated with ridership, so is associated with ridership decline, whereas the proportion of residents who attended high school but not college is positively associated with ridership decline. And we're actually seeing the opposite effect in Minneapolis, which means that, you know, there's more, you know, that there's more to these results than just, you know, the proportion of white residents, but it is striking that that is, you know, the one significant variable across all agencies. And it's not just because we're, you know, looking at all these other variables which are collinear. When you just look at the share of white residents, and you compare that with the log relative change in bus ridership, you can see that there is a negative relationship in all 4 agencies, with here, you know, the red trend line showing all route segments being weighted the same, whereas the green trend lines gives a greater weight proportional to the ridership, so that, you know, the places where there was very little ridership in the first place aren't weighted as much as the places that had very high ridership in 2012. And you can see that the relationship is negative in all 4 agencies. The slope is slight, but you should also consider that, you know, 1 on this scale represents 100% increase in ridership. So now I'll talk a little bit about the conclusion, and there's, you know, 2 main sets of conclusion. The first one is that at one point in time, the routes and the segments with the highest frequency are the most productive in terms of passengers per trip. Over time, though, ridership is inelastic to frequency, which means that added service generates less ridership than the average bus that's already running on the route. And finally, what we see is that low frequency routes are the most elastic in Portland, Miami, and Atlanta, but not in Minneapolis, which still has a lot of potential growth on the most concentrated part of its network. The second set of conclusion, based on the analysis of who's ditching the bus, is that at one point in time, the proportion of local residents who are college educated or who are seniors is negatively correlated with ridership. But over time, the proportion of local residents who are white is associated with ridership decline. And that, you know, is not to say that in neighborhoods that have a, you know, small proportion of local residents who are white, ridership is not declining. No, ridership is declining across the board, but more so in places that have a high proportion of white residents. And this indicates that some common cause of ridership decline may be linked to changes in the travel behaviors of local residents who are white. So with that, I'd like to remind you to take the brief survey to help Stride plan for future webinars. And this survey can actually be found in the comments section of this webinar. And also, I want to thank everyone for listening today. I want to thank my co-authors, Sanskriti Joshi and Dr. Carrie Watkins. I want to thank Taylor Gibbs, who helped us in the data preparation phase of this research, and also our partners at Metro Transit, MARTA, Miami-Dade, and TriMet, who provided us with the data and also guided us through the process of understanding some of the local dynamics of bus ridership in their own transit agency. Finally, I want to thank Tom Kowalski and Rashad Strickland, who work at companies that provide APC data for helping us understand the technology. With that, I will take any question, and I think Ondine is going to facilitate this process.
Yes, so thank you so much for this really interesting webinar, and thank you everyone for joining us today. We do have a link to the New York Times article in the chat box if you'd like to look at that. If you have any questions, please feel free to either write them in the chat box or you can also unmute yourself and ask it verbally. So we'll have open time here if anybody has any questions.
So if we don't have any, or do we have any questions? So maybe at this point, let me say that there are some upcoming webinars that Stride is hosting on May 13th. Dr. Virginia Sisiopiku from the University of Alabama at Birmingham will be talking about technology influence on travel demand and behavior. And on June 3rd, Dr. Nasseen Uddin and Dr. Vaiya Mohammed at the University of Alabama at Birmingham will be talking about flyby image processing for real-time congestion mitigation.
So we do have one question that came in on the chat box.
Okay.
Does the linkage in the decline suggest increasing income inequality?
That is possible, although I will say that yes. So I think that's possible, especially I think in places like Miami and Atlanta, but we're not necessarily so we didn't include income in this model because as part of this analysis we actually looked at the change in demographics. I didn't have time to go over that today, but I didn't want to include the change in income over time, because like people's income change over time, and so I didn't want that to confound the analysis. But I can tell you that, for example, in Minneapolis, the proportion of local residents who did not attend college is associated with a ridership decline. So it's not necessarily linked with income. I mean, I think it is in places like Miami and Atlanta, but it's not necessarily across all 4 cities. The fact that it's, and I think that overall income inequality, but also, some of the travel behaviors of people who have a higher income, like, ride hailing and telecommuting could very well be linked with this decline in ridership. But I think that there's also something that's geographical. When you look, and that is linked with race. In American cities, race is very much clustered spatially, and the reason for that are, because of decades of deliberate segregationist urban policies that mean that many of the non-white neighborhoods were built around public transportation, and public transportation, or these bus networks, were also built around these neighborhoods. And so although we don't have a tested explanation for why white neighborhoods are losing the most ridership, I think it's possible that there is also a spatial explanation that's linked to those specific places.
Great, thank you. Does anybody else have any questions? And if you do, you can unmute yourself or put it into the chat box. Oh, we have one more. Transit agencies would like to increase frequency on productive routes, but the issue is funding. What do you do?
Yeah, so so I think what we have here is a tool to anticipate the ridership impact of a frequency change. Basically, the expected impact of increasing, adding one more bus on a route is going to be the route's current productivity, so the average number of passenger boardings per trip, times the elasticity. So, you know, if you look at this graph, for example, you know, I would suggest for transit agencies to increase ridership without having access to additional funds is to look at the places that already have the highest productivity, so that are towards the top of the graph. And also for, you know, for Portland, Miami, and Atlanta, especially look at the routes that have a combination of high productivity and low frequency, because we know that in these three cities, low frequency routes are the most elastic. So for example, this route in Atlanta, you know, has possibly the greatest potential for growth because it has a combination of high productivity and high frequency. In Minneapolis, on the other hand, I would prioritize routes that have high productivity and high ridership. So these routes would, you know, I think should be prioritized with the objective of maximizing ridership. Now, of course, maximizing ridership is not the only objective of transit agencies. They also strive to provide accessibility and you know, mobility, especially to places of strategic importance. But if, you know, but in order to be able to make sound policy decisions, it's important to get an understanding of what will be the impact of those decisions. And I think that's what this research does, is it provides a framework in order to anticipate or at least understand the relationship between service provision and ridership.
Great, thank you. Do we have any, are there any examples where any of these 4 case studies are using the data or intend to use the data to change their routes and try to see how it impacts ridership?
Other cases, so you know, this is part of a broader research effort, and we're working with these transit agencies to dig even deeper and you know, disentangle these trends by time of day in order to see not just where should transit agencies be providing service, but also when. In addition to that, we are looking at the impact of ride-hailing usage using a very exciting data source that, you know, provides the data on a pretty disaggregated level, and looking at how ride-hailing ride-hailing usage is connected to the change in bus ridership over time.
Great. I don't have any other questions coming in at this time. If nobody wants to unmute themselves, maybe we'll just give a few seconds here to see if anybody has a verbal question. Okay, super. Thank you so much for today's webinar. And I would encourage you, if you're interested, to check out our other STRIDE webinars on our website. And we will in the future be highlighting other aspects of this research project as data becomes available, as well as other research projects. So please check out our survey. In the chat box is the link. And we look forward to having you on future webinars.
Thank you all, and thank you for STRIDE for sponsoring this research. We're excited to see where it goes next, and we'll be happy to report on our results.